In this video, we're going to look at decision making with probabilities. If you don't have a workbook with this information on it, you need to pause the video and lay something out like this. Don't worry about the subscripting if you don't want to. You should know how to do that by now, though. So in the text, they have added to our model, our building of a condominium complex, small, medium, or large option, and the strong state of nature values as well as the weak state of nature values. I changed this one so that it would work a little bit better. I think it's -9 in the textbook, but I've changed it to 2. Just makes it a little clearer for our purposes. I'll draw a line here for you. What we do now is calculate the expected value of the project using the best option. This is a profit maximization exercise. We'll calculate the expected value for each alternative by weighting the states of nature for that alternative with the probabilities for each state of nature that we've been provided. So we were given an 80% probability of a strong economy and a 20% probability of a weak one, weak market economy, whatever. So we'll use the sum product function to weight those to find the expected value of each alternative. Here is the alternative. I'll leave that relative. And here we have the probabilities. I'll make that absolute. That way when I copy it down, I should have the expected value for each alternative. There we have it. Place my cursor here, press F2. Yeah, I'm processing the correct numbers. Then I'll make the choice. You can see the choice there. It's 16.4, but again, sometimes these models can get lengthy. So I'm going to use an if statement. If the value to my left equals the maximum of the values to my left, make that absolute, then it's the best choice. Otherwise, a blank. All right, and I'll copy that down. All right, we have the best choice based on EV, economic value. Next, we need to look at our regret alternatives. You may need to pause the video to place these titles on your worksheet if you don't have a worksheet with those. What we want to find in the regret analysis is our expected opportunity loss. In other words, we want to minimize the opportunity costs associated with the choice that we make so that we make the choice with the fewest, the lowest opportunity costs associated with it. This is a profit maximization. What we want to do is take the maximum of the values of the strong state of nature. We'll make that absolute and subtract from that the value for our alternative, the alternative that we're in the small alternative for the strong state of nature. Gives us a value of 12. We'll copy that down. Do the same thing here. We'll take the maximum of the weak state of nature values, make those absolute. We'll subtract from them the weak state of nature value for the current alternative. Copy this down. Then I'll go ahead and calculate, weight them using the sum product. I'm going to weight the state of nature values for each alternative. I'll make that relative. Using the probabilities for each state of nature, again, that we were provided, and make that absolute. And copy this down. Then again, I'm going to look for the minimum value here. If the value to my left equals the minimum of the values to my left, make that absolute, then it's the best option. Otherwise, blank. I'll copy this down. And the best option is the large alternative. The final section for decision making with probabilities in a maximization environment is to calculate the expected value with perfect information. We've calculated the expected value, and then to find the expected value of perfect information. We may want to purchase research or study or something. It gives us some sense of the value of such an item. All right, to do that, we need to find the best outcome. The maximum outcome is going to be the max of the strong state of nature for each alternative and the max of the weak state of nature for each alternative. We have our probabilities for each alternative. We could re-enter those, but we can just go ahead and use these if we like. What we need to do to calculate the expected value with perfect information is to take the sum product of our maximum outcomes times our probabilities for those outcomes. Just weight that. That gives us the best case value. Then we want to take from that the expected monetary value of the project as it currently stands, the expected value without perfect information, or the EV, which we already have. We'll just take the max of our EV. We could have just put in 16.4, but it's better to use max in case you use the model for something else. And then our expected value of perfect information is simply the expected value with perfect information less the expected value, or the expected value without perfect information. And that gives us a value of 1. Let's just increase the decimal there to make sure. Yeah, a value of 1. So that would be the expected value of perfect information in whatever units these numbers are in. It could be 1,000, 100,000, 1 million, whatever the unit of measure is. That's how you formulate a model using decision making with probabilities when you want to maximize the outcome. Now let's consider the decision making with probabilities when we want to minimize our results. So we are dealing with costs or some value that we want to keep at a minimum. We're going to calculate the expected value in the same way. We have it set up much the same. If you don't have this set up like you see it here, you'll need to pause the video and get things set up so we have our model ready to go. Again, as in the previous example, we're going to take the sum product to find the expected value of the project. We're going to weight the state outcomes for each alternative by the probability of those outcomes, and I'll make that absolute so I can copy it down. And in this case, the best choice is to minimize these. So if the value to my left equals the min of the values to my left, make those absolute, then we have our best outcome, otherwise blank. And I'll just copy that down, and you'll notice that what I'm doing here is I'm just taking the formatting out as I copy it down. It's messing up my formatting because it's bringing these lines down, so I just take that out. Now, to calculate the states of nature in the regret matrix in a minimization problem, we want to take the value for the alternative in that state of nature and subtract from it the minimum of the values for that state of nature. And I'll make that absolute. And I'll copy that down. Do the same thing again here. The value, the alternative for that state of nature, less the minimum of the values for that state of nature. And then I'll copy that. My expected opportunity loss, again, is just the sum product of these. So sum product of the states of nature for the small alternative times the probabilities of those states of nature. Make that absolute so I can copy this down. And I'll go ahead and adjust the formatting here. I'll give it a extra decimal so I can see a little better. And then the choice here again is, as is the case in the regret matrix, is the minimum. So if the value to my left equals the minimum of the values to my left, make that absolute, then we have the best alternative, and otherwise blank. And I'll copy that down and get rid of that formatting. Now, to find the expected value with perfect information, we need the minimum outcomes in this case. So we're going to take the minimum of the outcomes for each state of nature. For this, there's the strong state, and I'll take the minimum for the weak state. The expected value with perfect information is simply the sum product of these minimum outcomes weighted by the probability of those outcomes. The expected value without perfect information, or the expected value, we've already found that. We'll take the minimum of our values, our expected values up here. Now in this case, in a minimization problem, the expected value without perfect information, or the expected value, will always be greater than or equal to the expected value with perfect information. So if we want to know the expected value of perfect information, we have to reverse our equation here a little bit. We'll take the expected value less the expected value with perfect information, or you could take the absolute value of the two. That would always work as well. That's up to you. That is how you set up a matrix for decision making with probabilities in a minimization environment.